So this has to do with and or. You guys, I don't know, maybe, do you remember like the and with that symbol and the or with this symbol?
Yes.
Okay, that's what we're doing today. Let's review a little bit what we once knew or maybe didn't know, I don't know. So if I say x is, let's say, less than 1, and x is less than 3. Okay, if I combine those with an and, what does that mean? Well, x is less than 1, what does that look like? Right? Because all the numbers less than 1 are this way. X is less than 3, kind of similar, going that way. But if I say and, what numbers am I actually talking about?
1 and 3.
Okay, is 2 less than 1?
It's only less than 1.
Right, is 2 less than 1 and less than 3? No. Is 1 less than 1 and less than 3?
No.
No, it's not less than 1. So it's really, is 0.999 less than 1 and less than 3? Yes. So it's really all these numbers right here. So it's this. When you have an and on the graph where they're both at, because it's got to be this and that, that's like the answer. So for the final answer, it would be basically just x is less than 1. So all that. Okay?
Oh.
However, what if I change this to an or? Now what's the answer going to be? Okay, is 2 less than 3, less than 1 or less than 3? Yeah, because it meets one of the qualifications, right? Less than 3. Is 1 less than 1 or less than 3? Yes. Everything. Is 3 less than 1 or less than 3? No, it's not either. So with the or, if it's true on one of them, it's true. Does that make sense? So with the or, we would start all the way back here. If it's covered by one of them, it's part of the answer. So it really, on the or, it would just be x is less than 3. So the and is more exclusive, and it only works where they're both at. And the or is like inclusive, like everybody's welcome. So it starts all the way back here. Does that make sense?
Yeah.
So the and only where they're both at, like in this region, and the or is where either of them are at. That's part of the answer. All right, that's case number 1. Let's try case number 2, going in opposite directions. X is greater than 1 and x is less than 3. So greater than 1 looks like that, less than 3 looks like that. Now if I say and, what numbers are greater than 1 and less than 3?
1 and 2.
Yeah. 2 would be one of them, but what about like all the numbers in here, like 1.5 or whatever? Is 1.5 greater than 1 and less than 3? Yes. All the numbers in here. The and is where they're both at, so it would be like this. Now, if you want to say all the numbers from here to here, what's the best way of writing that? Well, it looks like this. 1 is less than x is less than 3. So with an and statement, you can kind of combine them into one long statement. This says at the same time that x is bigger than 1 and it's smaller than 3. And that's what it looks like on the graph. Okay, but what if we change that to an or? Whoopsie. X is greater than 1 or x is less than 3. So now what are we going to use? Well, is 2 greater than 1 or less than 3? Yeah. Is 4 greater than 1 or less than 3?
Yes.
Is 0 greater than 1 or less than 3?
Yes.
Yes. So what's the answer? Everything. So if you think about these lines, what do they cover together? Everything. So every number, every possible number is covered. because they go forever this way and forever that way and they overlap. So the final answer for this one would be all real numbers, and the graph would just be, you know, solid line. Okay, so that's kind of a weird one for or. And then the third case is x is less than 1 and x is greater than 3. So what's this graph going to look like? Less than 1, greater than 3, opposite directions. It's a big old arrowhead there. So what numbers are less than 1 and greater than 3? Hayden says nothing, is he right? Can you think of a number less than 1 and greater than 3? No. So look at the picture. Do these two have anything in common? No. And has to be where they're both true at. They have nothing where they're both at. So this would be no solution. Null set. Empty graph. But what if I change it to an or? Is 0 less than 1 or greater than 3?
Yes.
Yes. Is 4 less than 1 or greater than 3? Yeah. The or makes it okay. They don't have to be together. So the final answer would just be all the numbers less than 1. I mean, it would just be this. Or all the numbers greater than 3. Does that make sense? A little bit? Not a bit? Somewhere in the middle? Okay. Number 1 says match each compound inequality to its graph, then state the solution set. So I'm going to do a little sketch here to help myself out. It says x is greater than negative 2, so that would look something like that, right? Or greater than or equal to 4. So 4 is over here somewhere. Greater than or equal.
Draw the graphs.
No, this is just to help me figure out the answer. So if this is an or statement, what am I going to use? Okay, if it can be this or this, then all these numbers back here would be included. If it's covered by either of them, either on the or, then it's part of the answer. So really, the answer would be all the numbers that are greater than negative 2. You guys follow? So this is one of the answers that they wanted for this, and the other one was what graph it goes with. So which graph is x is greater than negative 2? D. Alright, you guys getting that? No?
Yep.
Maybe I have to ask you some questions. Number 3, x is greater than negative 2 and less than or equal to 4. Okay, so it's negative 2 and 4 somewhere on the graph. X is greater than negative 2, so that's all this. Less than or equal to 4, so that's going the opposite direction. So, Shannon, what would that include if we combine those with an and? Huh? F. I'm asking what numbers would be included if we do this and that. Okay, right, all the numbers between negative 2 and 4. Now, what kind of circles would we use? Well, this one is not included, and this one would be included because it's in both. So we can just copy this. So, what'd you say earlier? F? Yeah, you were right. It's F. And what's the best way of writing the numbers between negative 2 and 4? Negative 2 less than x, less than or equal to 4. So this would be the answer. it says less than -2, greater than or equal to 4. So they're going in opposite directions. Less than -2, greater than or equal to 4. Oh, and we're connecting with an and. It's an and statement. So, Willow, okay, Hope.
Would it be none?
Yeah, it would be none. Why is it none?
Because nothing would like overlap.
Yeah, there's no number over here and that's over here also. There's no overlap. So it's nothing, which would be a. So for the like solution set, they just put the null set and the A is the empty graph. Number 7. Okay, so 7 says Fraser firs, evergreens often used for Christmas trees, grow in regions 5 and 6 of the climate map at the beginning of this section. So you have to turn your page back one to look at it. Write a compound inequality to describe the average annual low temperature T of the following areas. Then number 7 says areas in which Fraser fir grow. Fraser fir grows. Sounds weird. Okay, so if you look at that colorful map over there, the direction said they grow in regions 5 and 6. So how would we write the temperature range for regions 5 and 6? What is the temperature range for regions 5 and 6 for zone? 0 to -20. Or if you want to start with the low one, it's -20. You guys see where she got that from? So how do we show that the temperature needs to be between -20 and 0? Okay, it's kind of unclear with that whether it's less than or equal to, so I'm not going to worry about it. Well, I'll just say less than or equal to. So it's got to be, the temperature's got to be bigger than -20 and less than 0. So it'll look like that. Or you could write it backwards. 0 is greater than the temperature is greater than -20. That would be the same thing. Okay, if those are the temperatures that the trees can grow in, number 8 asks, what's the temperatures where the trees would not grow?
Less than 20.
Less than -20
More than 0.
or more than 0. That make sense? If they grow between 0 and -20, then they won't grow less than -20 or greater than 0. I guess just to think of it. I'm not going to pay attention to the greater than or equal to thing on that because there's overlap. Okay. Number 9. Now we're doing a little bit of solving inequality stuff. Okay, when you have a combined inequality like this where there's kind of 3 parts to it. You guys see it? It's like this, less than that. What it means is 3 is less than x plus 2 and x plus 2 is less than or equal to 9. So it's kind of like 2 separate statements, but you can solve it like it's one statement. You can solve it all at once. And the way that you do that is just like here we would just try to get x by itself, right? So up here we just want to get x by itself in the middle. You guys follow? Yeah, show a little bit of work. Okay, how do we? Every time.
Subtract from
subtract, is that what you said? Subtract?
Yeah.
Okay. How do we get x by itself? Minus 2, minus 2, minus 2. Let's do it to all sides.
It's like I'm a slave. You are.
You are a slave. You're just now realizing this? Yeah. Yep.
I was gonna ask. I just never looked up. When she comes back, can I?
We'll see. We'll see what mode I'm in.
Is that the answer?
Yeah, did they ask to graph on this one too?
Oh.
So, I think they did. Did they ask to graph? Lies. Okay, how do we graph this? X is between 1 and 7. So all you have to do, you don't have to be that pretty. We'll just do this. 1 and 7.
You're rude.
7 is included, so that should be, and then it's everything between there. So that would be the graph. Okay. Number 11 is two separate statements connected with an or. Guess how we're going to do this one? You're just going to solve them separately, just like they're two different things. So, pretty basic. I'm going to go very quickly. I wouldn't like copy me, I would just do it yourself and then make sure we're in agreement. Yucky.
When we do it
Look
with
at that
you,
word,
do
isn't
we
that
have
cool?
a short word?
Huh?
If we do like the odds, do we have a short word? Because we're doing, like we're doing it with.
If you're doing it with me, then you would be doing it though.
Yeah, like in our head mentally, and we're watching you do it.
Go ahead and show a little bit more.
No.
You guys like my or?
Yes.
You see, it's so nice when she asks.
Because
It's like you want. Yeah, it's a you. Yeah. I'm lazy.
It's because you ask like every day and then you whine about it when I say yes.
Because it's so. You're just proving it's smart.
All right. So let's do a floating line thing. There's 1, there's 5. X is less than or equal to 5 or greater than 1. What would that include? All the numbers less than or equal to 5 or greater than 1, what would that include?
It would include 1 all the way up to 5. Oh, just oh.
All right. The or, if it's covered by either of them, it's included. What's covered by either of them? Everything. So it's all real numbers and a solid line. So these are the two answers.
So fancy looking on.
Yeah. You guys remember the fancy art?
I do know. What's that drawing for grade? It's not drawing, it's handwriting. But with 2 lines. So bad.
Do you see the?
Well, I mean,
This is number 11. I solved them both separately, but you might have to just do it on your own there.
What?
So on 13, they're just two separate things again, so you solve them both separately. What did that TP looking thing mean? This symbol? Well, that means and, because it looks kind of like an A, right?
Uh-oh. Are there any fractions?
Probably.
No. Man, I'm dead.
But actually I don't see any.
Okay, well, that's good.
Is number 10 a fraction?
Whoopee.
No.
Wait,
Well,
I want, oh, did I do it?
hold on, let me check.
Yeah, I think I want the thing.
Yeah, there is a fraction on 10.
Yeah, I knew it.
Shut up.
You don't like me?
I really knew it.
I don't.
Leo, Leo, knew it.
Did I use the restroom?
I was when.
May I use the restroom?
Yeah.
What?
Yeah,
Oh.
Nope.
Yeah.
like me. Okay, solve them separately.
Child labor is the way to go. If you're restless.
What?
So remember when you divide by a negative.
I'm kind of behind.
Okay, so
Uh-oh.
it's got to be less than or equal to 4 and greater than or equal to negative 4. Can you guys picture that in your head, what the answer would be? Less than 4, greater than negative 4. Nobody knows? Less than or equal to 4, greater than or equal to negative 4. What would that include?
Everything between 4 and
No,
4.
that would be an or. Okay, what numbers are greater than negative 4 and less than or equal to 4? All the numbers between. So it's connect the dots. And the best way to write that is x is between negative 4 and 4. So these are the two answers. Olivia, I heard you guys won your tournament.
Yeah.
Congrats.
Thanks. So that second thing, do we have to have that one, or can we just have the first one?
I do want us to start combining them, so yeah, I do want you to write that one. I want you to try and simplify if you can. Sometimes you can't, a lot of times you can. For full credit. Okay, let's see, are we skipping 15? What was the thing? Yeah. So we're jumping to 17. These are, we don't have to graph these, but they're kind of beefy.
There's pencil shavings. Have to get them off. I can't use my fingers, it's too big. Pencil's small. Sorry. Oh.
I just copied 17 down. So guess what we're gonna have to do?
Oh, yes.
Well, we're gonna have to solve them both separately. That's kind of like two of Friday's problems put together. And that's basically mostly it. So what do we do when we have y's on both sides? Subtract, oh, is that a y or an x? Those are y's. Okay, it's basically just two separate problems. You guys see it? It's this one and that one. So we're just gonna do them separately. So I'm gonna subtract 3y, get rid of y's on one side. Okay, so that was pretty fast. I've got 2 is less than y, which is the same thing as y is greater than 2. over here, we've got distributive property. What would happen if I added 2y to both sides on this one? The y's those would go away, yeah. So I just have 7y plus 8, 43. So I've got y is greater than 5. Okay, however, that could be the answer, but I want us to simplify it if we can. What numbers are greater than 2 or greater than 5? Here's a little mini graph. What numbers are greater than 2 or greater than 5? Greater than, it would be greater than 5 if we're doing and. So it's greater than 2 because we're doing or. So that means if either of them, either this or that covers it, that's part of the answer. So y is greater than 2. If you want the full credit answer, you have to do that one. But we don't have to graph it this time. Even though I graphed it to help us figure out the answer. Wait, hold, Ega, last one. It's the last one in Chinese. What's different about this one? I forgot about this one. Okay, this one's a little bit of a doozy because it's kind of like number 9. Yeah, it's got like 3 things hooked together like that, and that. But we can't get A by itself in the middle because we have A's out here, and it's just not gonna work. So we're gonna have to separate it into 2 separate ones and work it like that. So I broke it up into 2. This is connected with an and. And I'm just going to solve them separately. Parts sold separately. Girls.
What do you think? Says you last year. Me.
Okay, because we are dividing by positive 2, we're not going to flip the inequality. So I got A is greater than 5 on that side. On this side, hopefully you guys are kind of comfy enough with, you know, basic algebra that I'm not totally blowing you away here. So I'm going as fast as I can. So I got A is greater than 5 and A is less than -2.
Can you go back up to where you?
Did I copy that right? I did something wrong.
I thought it was 5 o'clock.
I copied something incorrectly. 2A, I did something wrong. Oh, that's a -5. Let's see. And is this a positive 2 also? Could I screw it up twice? No mistake, that one's right. Alright. So, what numbers are greater than -5 and less than -2? Here's -5, bigger, less than -2, smaller. So, looks like this, greater than -5, less than -2. So what does that include?
Negative 5, negative 2.
All the numbers between those. So it's -5, -2.
Do we have to double those?
No. I'm graphing to help us figure out what the final answer should look like.
So, I mean, it's
Okay, I've got a hint to, well, it's not a hint, it's just a good policy. You don't have to do this on number 20, but if I was doing it, actually maybe somebody can guess what I would do first before I say. Okay, this is the left side of number 20. Anybody have a guess what I might do first?
Distribute.
Okay, you can do a distributed property like normal, but there is another method. Okay, I would multiply both sides by 6. You guys know why I would do that?
2 times 3 is 3.
Because 2 and 3 both go into 6, and when you multiply, what's 6 times a half? 3. So you multiply terms on both sides by 6, and that side becomes a 3. This side becomes 1/3 times 6. 2. Okay, so that got rid of the fractions. You don't have to do that, but it makes it easier to not use a calculator and do it this way. Either way, you should get the right answer with the same answer. And you can do a similar trick on the right. If you don't want to, you can stick with the fractions. It'll still be okay. Alright.